Let me pause it. And so we will talk about that today.
Okay, thank you.
You bet. All right. So this is our third class of the semester. We go through 28. We've got 28 lectures in this semester. So your first homework assignment is due before class on Thursday. And remember that the way that you submit your assignment is that you do your hand calculations either on like just a white piece of paper. It's better if it's not lined paper because a lot of the cash flow diagrams that we're going to have, lined notebook paper would make it a little bit hard to see. And so my suggestion is just use like plain white printer paper, you know, where it's just blank. Or you can use that green engineering computation paper. And Ben, I see you've got some of it there. Could you hold that up? So the engineering paper has the graphs on the back so that you can draw cash flow diagrams and sketches to scale, but then when you scan it, the graph actually doesn't come through on the scan since it's so faint and it's on the back of the paper. So that's my recommendation. Now for this assignment, if you've already started working on ordinary lined notebook paper, you don't need to throw it away and start over. That's all right. But I really think that it's a lot easier for me to see your work and for you to sketch good cash flow diagrams if you don't use notebook paper. So turn it into a PDF using either Cam Scanner or Adobe or some other method, and then upload the PDF before 4 o'clock. I'll have office hours tomorrow. If you need help, I'll have office hours on Thursday, although that's cutting it pretty close because I think my office hours on Thursday are from 2:30 until 4. So hopefully you'll get a start on the assignment before then. Any questions, any other questions about the homework assignment? Go ahead.
So you just need like answers, or you want steps like calculations, everything?
Good question. What I think you should do is you don't have to write the entirety of the question out, but if you do, that's also useful. But some sort of summary of the problem statement, if it's abbreviated or so on. But then, yeah, show your steps along the way. Don't just have the final answer, but I'd like you to see, you know, what were the calculations that you did. And the reason for that is if you show me your work and there's a mistake along the way, then I can identify, I can show you where is the mistake, and it would help you to learn from the issue and correct it in the future. And then also you get partial credit. Whereas if you just have only the final answer and it's wrong with no supporting work, then I couldn't give you any partial credit on the assignment. So that's a great question. Ben?
Regarding significant figures,
Mm-hmm.
I noticed like in the in-class exercises that, I don't know if you can just maybe tell us what you're looking for in those.
Yeah.
Like I always made the assumption that if there's sense in the problem, then take sense in your answer. If there's just whole dollars in the problem, go to whole dollars in your answer. But I didn't know.
Yeah, good question. It depends on if you're using the factor method or the equation method, how precise to be in your final answer. So for example, if you looked up in the back, we're going to talk more about the factor method on Thursday, but you probably remember from that in-class exercise, it may be the concept inventory. Let's just say, for example, that you know P to F is 0.6347. And you got that out of a factor table. So then let's say that you know that the future value is $100 exactly. So then the present value is going to be 100 times 0.6347. So in that case, it would be $63.47. So it is to the nearest penny. But then what if, instead of $100, what if it was $1,000? So in that case, then your P would be $634.70, but we don't know necessarily whether it is exactly zero there. Maybe it'd be better for me to even make it a bigger number than 1,000. Let's say 10,000, because I think that maybe is going to illustrate the point more clearly. So it would then be $6,347, but it's not to the nearest cent because if you only have 4 significant figures in the factor that you're using, then there would only be 4 significant figures in the answer. And so you wouldn't say 0.00 because you don't know if it actually is to the nearest penny. So that's the answer. That's kind of the guidance I'll give you. Some of the factor tables have 5 digits or 6 digits. Some of them have only 4. So round off your final answer to the same number of digits in the factor that you've got.
But if we're using an equation, we should be precise.
Exactly.
Okay.
Because you are in control of the significant figures then. If you've got the equation, for example, future is present 1 plus I to the n, and I is 0.0932, and n is 7. I mean, you could calculate that factor, what's inside the parentheses there, to like 16 digits of precision, and then you just round off to the nearest penny there. Okay, great question. I'll be kind of lenient on this first assignment while we all still get a feel for it. I probably wouldn't deduct points if you made a significant figures error, but I would point it out on the assignment just so that you could correct it in time for an exam. Because on an exam, if you made an error on significant figures, then I'd have a very minor deduction there. Okay, great questions. All right, so today we're going to be talking about cash flows and a little bit more on how to visualize amounts. And then following that, we're going to also talk about more on economic equivalence. So in the cash flow diagrams, there's a standard system of notation. There's standard approach to the top side of the cash flow diagram and the bottom side of the cash flow diagram. We've kind of touched on this so far. And the money that you get, sometimes in a problem statement, it would be described as revenue or receipt or income. All of those things are money that's coming to you. And then this word savings is kind of a tricky word that you have to be very careful about the word savings. Because if a problem statement said that you saved $1,000 with no other information, just that you saved it, probably that sounds like you were making a deposit in the bank, that you were putting aside extra money so that someday in the future you can withdraw the money. So everybody here has heard that usage of the word savings before. But then there's also another usage of the word savings, and that is an expense that you used to have. So for example, if we invested in more efficient windows in this building, then we would probably be saving on our heating costs because less cold air would come into the building. So if we made some investment and then we were saving on the heating costs, then the savings, meaning the amount of money you used to spend on some expense, but no longer do you have to spend it because you made some investment and now your future costs are lower, that reduction in future costs is considered as an inflow. I know that's tricky, but just as an example, if you bought a more fuel-efficient car, you paid the money today to have a more fuel-efficient car, but then over the course of 10 or 20 years, you're going to be saving money that you used to spend on gasoline. So you can consider that future reduction in fuel costs as an inflow that may justify your lump sum outflow at the present. So if you had some present expenditure, let's say you bought that new Prius that's just coming out this year. I think it's maybe around $28,000. So the question might be, if you plan to keep your Prius for 20 years, which is doable, Toyotas last a good long time, and maybe these days you could get an auto loan and the time value of money, interest rates is maybe 6%, for example. So a question may ask, how much fuel do you have to save to justify buying a new car just for the improvement in fuel economy? So then it would be some unknown future amount in a case like that. So savings is just a reduction in prior expenses. Okay, I think everybody's got that. Outflows are money that you pay, and so those could be costs of producing goods. It could be pay that you give to employees, any kind of disbursement or expenses, taxes that are generated. So we consider that as an outflow. So a minus sign is used when we're doing time value calculations, or it is an arrow downward on the cash flow diagram for outflows. And the net is the difference between the in and the out. And so sometimes net cash flow is known as revenue minus costs equals profit. So a net cash flow could be the revenue that you're getting where you've subtracted out the costs of generating that revenue. Now here's this thing that's related to what Jake was asking at the beginning of class. He was saying, if you are, for example, going to be saving $1,000 a year in fuel costs because you bought this new Prius, how would you represent that on a cash flow diagram? And the end of period assumption says that we've got a 1-year period starting from today and 1 year into the future. And the end of period assumption says that let's represent what's happening within that year as a lump sum at the end of the period. So if you're saving money, because you're driving that Prius every day, right? And so you could do like a cash flow diagram where every day has a tick mark on it. But that would be unnecessarily complex and long. And so it's okay to aggregate all of the financial transactions in a year and then just represent it as a single instance during the 1-year period. So the end of period assumption is saying that you put all of the savings in fuel during the year from 0 to 1 as just a single lump sum at the end of that period. So that's the end of period assumption. And unless a problem says otherwise, unless it says use the beginning of period assumption, you will always apply this end of period assumption. And Excel does the same thing. When we're doing calculations in Excel, that's the default assumption that Excel takes, is that cash flow amounts are at the end of each period. So it's useful to represent cash flows as a graphical representation because it's more simple and streamlined than these English language problem statements. And I think I've shown you one of these before. You know, you can have a statement that's written out in text, or you could translate it to a diagram that's just easy to see and is language neutral. And so in a problem like this, for example, if you're borrowing the money and it says in 5 years how much do you have to pay back, this implies that you're receiving the money now, and it's $10,000, and 5 years that would be an outflow, and so you'd have to have an arrow downward 5 years in the future. So this is illustrating that today you're getting $10,000 and it's a solid line, meaning that we know the magnitude of the amount. You can see it's labeled as present, and then the amount that we would have to pay is 5 years from now. And so if we count the number of years, here's year 1, year 2, and so year 2 begins at the end of the first year, and it extends through the end of the second year. And so 2 is a single instant in time. It means the end of the second year. But the second year is a period, and so it has length on the cash flow diagram. So that's sometimes a little bit tricky when you're translating these words. It's saying like after 5 years, and so you have to remind yourself, after 1 year is here, after 2 years is at 2, after 3 years is at 3, and so on. So after 5 years means that you'd put that arrow right on the 5 tick mark, and it's down because we're going to have to pay a certain amount. It's labeled with the F because it's just to draw attention to the fact that this is some future quantity and we don't know the amount, so it's a dashed line, and these question marks reinforce that as well. So we can translate cash flow statements into cash flow diagrams. So these symbols, it's sometimes useful if you have a statement like this to write the labels right on above or next to the variables on a test. I think this is a great idea on an exam. So for example, just to help you translate it, you could above where it says you borrow $10,000, you could just write P right above that $10,000. And then when you see the interest rate, you could say I equals 0.06. Because if you're doing any calculations, you'd probably need the decimal representation of I. You wouldn't use a whole number. So above here, you'd say I equals 0.06. And then here you see 5 years. And so N equals 5 right below there. So I think that's a good habit that you can use. And then how much should be repaid? You could just say, you know, the how much must be repaid. This entire statement is effectively F equals question mark. So we've got this standardized notation, and then we can also, when we have problems like this, put it in parentheses, the types of problems that this is. And so in this problem, P is the given, F is the unknown. So our standard approach here is that we have find / given, boy, my spelling is so bad today, given, okay, comma, I equals something, and then N equals something. So we've got this notation, and so this would be, basically, this is a find F given P type problem. I equals 6%, and you can either write it as the decimal or you can write it as the percent. Either one is okay in this kind of shorthand, and then N equals 5. Okay. Now last time we talked about the difference between annual compounding and monthly compounding. So what if the problem said you borrow $10,000 at 6% compounding monthly? So if it said compounding monthly, this wouldn't be our shorthand. What would be the shorthand now?
Divide 6 by 12.
Okay, so it'd still be F/P, find F given P, and then it would be 6 divided by 12, because we want to know the interest rate per period. And 0.06 divided by 12 months per year means that I is 0.005, and then N is what? 60. Right, good. So it's the same problem type, but we just have to be nimble when the compounding period is something other than annual. Any questions before we move on? Okay, cash flow diagrams can be fixed amounts or they can be ranges. So this illustrates if you had uncertainty about what some future payment may be, like maybe you're going to get between $135,000 to $150,000, then instead of just having a fixed length arrow, you'd have these dashed lines instead of arrowheads to indicate the range that the future amount might be. Now this A, does anybody remember what A stands for? Annual. It's either an annual series, sometimes it's called a uniform series. So A just means that the amount is the same every year, and that's why I didn't say like 150,000 above each of the arrows, because you can see the arrows are the same length and there's just one amount. So that means that you get 150,000 every year for 6 years. So that's an annual series. All right, so let me give you these in-class exercise problems, and remember that the format of these is I'm really happy to have you collaborate with your classmates on these we don't need to maintain reverence in the classroom while we're working on these in-class exercises. It's great if you want to chat, and I'll be circulating around with the answers. So this is just some practice for you to work on cash flow diagrams, problems 1 through 4.
If you were going to solve one of those annual range.
Okay, so the first problem says draw a sketch including labels. And on the homework, you should always include the labels. It helps to avoid mistakes if you've got the amounts not only magnitude right, but if you just kind of symbolically represent the perspective of when it is. So today you receive $10,000 from the bank, and then starting 1 year from today, you make 4 annual payments to the bank in the amount of $3,300. So today you receive $10,000, and so that is going to be an arrow that's up. Today you're getting the $10,000, then 1 year from today, starting 1 year from today, you make 4 annual payments to the bank in the amount of $3,300. Now it doesn't say that they're 4 equal payments, but that's implied because the only amount they told you was $3,300. So like if it wasn't equal, then you'd need to have more information about how the series of payments is changing. So you can infer from the fact that it didn't tell you any other information that it's $3,300. You just sometimes in problems like this you have to assume what's the most reasonable or logical thing in the absence of additional information. So it didn't explicitly say they're equal, but they are. And so this is an annual series, and the arrow is down, A equals 3,300. Okay, the second problem was you save 10,000 at the end of each year for 6 years, and then at the end of the 7th year you withdraw the balance, amount not yet known. So here's the tricky part. Do it from your perspective and then do it from the bank's perspective. And so if it's from your perspective, if you're saving 10,000, now here's this word that I was warning you about, save. Is this talking about a reduction of expenses, or is it talking about depositing some money because you're going to withdraw it again in the future? It's the deposits, right. So from the context, we can tell whether this 10,000 should be an outflow or an inflow from our perspective. So from our perspective, it's an outflow. There's 6 of them starting a year from today. No, let's see. It says at the end of each year. So here's the first year, and then at the end of the year is the 10,000 we put to the bank. At the end of the second year, 10,000 we put to the bank, and so on and so forth. And then at the end of the 7th year, you withdraw the balance. The dash, because we don't know the amount. The F, it's a future. Question mark reinforces that we don't know the amount. Okay, so that's our perspective, and the bank's perspective is just a mirror image of that, because what they see is that they see that they are getting $10,000 every year, and then 7 years from now they have to pay out some amount that they don't know the magnitude yet. Okay. So any questions about the first 2 problems? Just interpreting the language is sometimes the tricky part. The hard part's not drawing the sketch. The hard part is translating the language and understanding the intent. So that's why I think it's valuable for us to take some time to talk about the potential pitfalls, like some of the mistakes I've seen people make in the past on problems like this. All right, problem 3 was just translating a cash flow diagram into a cash flow table. So inflow amounts are the arrows that's above the line. Outflow amounts are the arrows that are below the line, and then the net is going to be the in minus out. And there are a couple of years, years 3 and 6, where there's both an in and an out. So we need to know the difference between them. Let's see. Yep, here we got it. Yes?
We don't continue to add up the net flow, you just do it for that instant.
Good question. It's just for the row in question. We could add another column that would be cumulative net cash flow, and we will do that. We will do kind of like a cumulative profits over time, but this is just for the year in question. That's a good question. I'm glad that you asked that. Yeah, for this one, it's just the isolated amounts. You're treating them like just a certain amount isolated at the year that it's described. All right, and then problem 4 was, today you get $25,000 from the bank, and in 3 years you're going to pay the bank $30,000. Draw the cash flow diagram from the bank's perspective. So this is, I don't know, it's almost a trick problem because it starts off talking about you, but then it says, it turns things around, it says draw it from the bank's perspective. Okay, now, is this an annual series like some of the other things that we've seen, or is this an F? Is this 30,000 an A or an F? F. Because it doesn't say that you're going to pay annually, and it doesn't say each year for 3 years. It just says, it just talks about in 3 years. So that's only talking about a single incident. So that's an F. So that's how we label it. We've got the P is the 25,000 that you, if you receive it from the bank, their perspective is that they had to pay you 25,000 today, and then in 3 years they get the 30,000. So it's kind of a trick question because there, here at the end, I told you do this the bank's perspective. Okay, so any questions about those first 4 problems? If not, then we will continue. All right, so P is sometimes called the present worth, and a present worth is where we're taking money from the future and finding the present equivalent of that amount by taking into account the time value of money. And now, today is our 3rd class, and each of the 3 classes I've used the phrase time value of money. And time value of money is related to that idea that we know prices are increasing over time. We call that inflation, the inflation of prices. And since the prices are increasing over time, the supply of money is increasing over time. What that means is that money today is more valuable than money in the future. So if there's a certain number of dollars in the future, and we want to know the present equivalent of that, there's going to be less dollars in present terms. Anytime we move money from the future backwards in time, closer to the present, then the magnitude of the amount is decreasing. That's called, if you are discounting. That's a verb, discounting. I'm going to write that on the board. Discounting. And we already talked about compounding. If you're compounding money, it's getting bigger, and you're moving it into the future. Into future. More amount. So compounding money into the future makes the amounts increase, whereas discounting, you're moving money to the left on a cash flow diagram. You're moving it into the past, or just from the future towards the present is maybe even better to say in the past, because today is time 0, and we don't usually go into negative territory on cash flow diagrams. What we do is we just say time 0 is the first year that anything happened. And so if your business started in 1960, then we would have time 0 is 1960. And then all of the successive years since then would have their own. So instead of saying into the past, let's just say closer to the present. Because you're moving it from the future towards the present. Maybe it will go all the way to the present. Maybe it'll just be going part of the way. But then it's going to be less amount. And that makes sense, right? Discounting, that phrase you've heard about, discounting. If you want to, if you get a discount from a company, that means it's less amount than it normally would be. So when you're moving money to the left on a cash flow diagram, the amounts are decreasing because you're discounting. If you're compounding into the future, then the amounts are going up. So the present worth is you're finding any amounts not in the present, you're finding the present equivalent of them. If you're moving things into the future, sometimes it's called future value or future worth, then the amounts are going to be larger than they were at the present. And then an annual worth is a uniform series of equal amounts. And here's the thing, is that they have to be consecutive with no gaps in between. So let me draw a cash flow diagram on the board. And what if it was that you got $100 2 years in a row, and then nothing happened, and then you got $100 if you had a gap year. This is not one continuous annual series with n equals 6. Here you'd have one annual series with n equals 2, and then you'd have another annual series with n equals 3. So if you wanted to find the present equivalent of all of these, you'd have to do it in more than one step. You'd have to find out, like this annual series, you'd take it to year 3, and then you'd move it from year 3 to year 0. And then this annual series you could take straight to year 0. But the point is, this statement here is that it's a series of consecutive equal end of period amounts. So anytime you see a gap, that interrupts your annual series, and you have to be aware of that. Any questions?
That can be inflow or outflow.
Correct. Great. Good question. It can be in or out. So economic equivalence, the time value of money, is just saying when you take into account the interest rate and different amounts through time, you're trying to translate money in the future to money at the present. You're trying to time shift. Sometimes you can pay now, sometimes you can pay in the future, like a house. You want a house now, but you don't want to pay the whole amount now, so you time shift that obligation over 360 monthly payments into the future. So how much should each of those monthly payments be? The economically equivalent value. So $100 now is economically equivalent to $110 in the 1 year in the future if interest rate is 10%. Okay, that's obvious enough because we know that future is present times 1 plus I to the n. And so if n is 1 and I is 10%, then it's 1.1 to the power of 1 times $100. The future will be $110. That's clear enough. Excuse me. Thank you. So we are time shifting the amounts, and we're finding the equivalent value. It's not saying that 100 is equal to 110. 100 and 110 are different numbers. But 100 now is equal to 110 a year from now if I equals 10%. So it's economic equivalence, not numerical equivalence. So here are some of these symbols again. We've seen them before. Now, what about if we know that we have $100 now and we're going to get 110 in the future? Now these, you've got a down now and an up in the future. So this looks like savings. So you're depositing $100 now and you're withdrawing $110 in the future. Now, we're not saying that a withdrawal and a deposit are the same thing because one is an outflow and one is an inflow. But the magnitude of the difference is economically equivalent. So if you deposit $100 now, then you're entitled to withdrawal of 110 1 year in the future. But it's important to keep the sign in mind. And by the way, it reminds me that I was going to point something out. On these, the arrow downward implies magnitude. So you don't have to put the minus sign in front of the A. Because from your perspective, you're losing $10,000 each year you make that deposit, but you don't have to say like negative 10,000. The arrows are already taking into account the direction, that it's an outflow. So you don't need to over-specify the direction of that being an outflow. So, okay. So this illustration is about magnitude, and so it's okay to say that $110 withdrawal is economically equivalent to a $100 deposit, as long as you understand why that would be, because you're making a deposit now, and so you can withdraw it in the future. But what if you're thinking about the perspective of a deferred payment? What if you are building a house for someone? If you're building a house and you say, you can either pay me a lump sum now, you can either give me $200,000 now, or in 1 year, I'm going to carry this construction loan at 8%. There's going to be some future amount that you have to pay me. It's economically equivalent. So the arrows are in both directions because it's understood that you, as the contractor, are entitled to receive either a certain amount now or a greater amount in the future. So we're kind of flexible on magnitude as long as the problem statement makes clear that, this is a deposit withdrawal situation, or maybe you're receiving deferred compensation, and so then the two arrows would be the same direction. Okay. Now, what if, I don't know, is the answer to this one in your notes already?
Yeah.
Oh, shoot, I need to find out some way so that you don't already see the answer in the notes. I need to improve that. All right. So if future is 100, sometimes students will mistakenly say P is 90. Just like by looking at it really quickly, they say 10% of 100 is $10. And so they think, well, P must be $90 because it's $100 minus 10%. But that, if you did that kind of mental approach without using the formula, then you would miss out on the fact that, remember, future is present 1 plus I to the n. And so if it's 1.1 to the first power, and we have the future value is 100, and it's the present value we're trying to find, then P is 100 divided by 1.1, which isn't the same as 10% off. So as you already saw from here, it's actually that you would have to have $90.91 at time 0, and then that earning interest of 10% would get you up to $100 in the future. So if it was just $90 at time 0, then you'd have 99 at year 1. So don't fall into the trap of just assuming like 10% off, something like that. Actually solve for the formulas. Okay, so I've talked about how there's a shorthand for different problem types. And this cash flow diagram is illustrating find F given P. So the future amount is unknown, the present value is known, so that would be find F given P. And so we have as a ratio F in the numerator and P in the denominator. And the reason why is then if we have that factor, let's say we go to a table and we find that the F to P is 1.5387. So then if you wanted to find the future amount, you just move the P to the right-hand side of the equation. So multiply both sides by P, then it would be F is P times 1.5387. So that's why F is in the numerator of these factors, is because normally you're going to have this ratio is equal to some amount or is equal to a formula that'll allow you to calculate an amount. Okay, this F is known, P is unknown, so find P given F is how we would restate a cash flow diagram like that. And then finally, oh no, there's two more. Find A given P, or find P given A. So you just get in the habit of the thing that is unknown is in the numerator, and the thing that is known is in the denominator of these ratios. All right, so now let's take a look at problems 5 through 7 in the in-class exercise. So problems 5 through 7, we're going to do some number crunching here. So the first one is related to the last problem on your assignment. On the last homework problem of your assignment, you've got a couple of different amounts that you're trying to find the lump sum equivalent of. So what I'm suggesting on problem 5 is use this formula 2 times to find F. Use it once on the 10,000, and then use it once on the 5,000, and then combine the amounts together to find out the lump sum future equivalent of that. All right, now I'll leave you to read the rest of the problems as well.
I have a question.
Sure. I also do want to show the solution. Okay. All right, so this problem 5, well, what was it on the handout? What was it? Okay, there's 10,000 that we are trying to move 5 years into the future. And so n equals 5 for that one. And then there's 5,000 that only has to move 1, 2, 3, 4 years into the future. So n equals 4 for that. They're both the same direction. And so we combine them together. And so what that means is if you made those two withdrawals, like if you got the money, then you would have to pay in year 5 $19,694. So what we're doing is we're treating each year as some individual present value. Now think about what we just did. This amount at year 1, it's not actually at the present. It's at year 1. But we used the formula find F given P, and we pretended like this amount at year 1 was at the present. We just changed our frame of reference. Like after we finished with the 10,000 amount, we said, just temporarily, let's pretend that this is times 0. And so when we did that, to move it here to the future, then if we have this quasi-present, which is really at time 1, but we're treating it like the present, then n equals 4 to get that amount 4 years in the future. So we're going to use that trick a lot, where this $5,000, it's not actually at the present, but we could still use this formula by pretending it's at the present. Anytime we have some amount like an annual series, for example, if we had an annual series that starts some years in the future, like this, so it's 1, 2, 3, 4, 5, 6, 7. So if we had an annual series like that, and we want to take it to times 0, what we'll do is we're going to play that same trick where we pretend that the present is 1 year before the annual series. And so we first find out what is the equivalent amount in year 3, and then we would take the lump sum equivalent of the annual series from 3 to year 0. So it'll kind of like be a 2-step process where we momentarily pretend like year 3 is the present, even though we know it's year 3. So that's just a preview of things to come with this strategy. Are there any questions about that problem? As I walked around, I think everybody pretty much got the right idea on that one. Okay. And then that's not the one. Let me pull up the other one. Got so many different ones of these over the years. All right, so we have a series of annual amounts, 12,500, and we want to find the equivalent amount in year 4 of it. So you can see that I labeled this as like A, B, C, and D, just to kind of illustrate which one I'm moving into the future. So arrow A has to move 1, 2, 3 years into the future, whereas arrow B only has to move 1, 2 years into the future, so n equals 2. Arrow C moves 1 year into the future, and since this D is already at the same time as the future, then we don't have to do any kind of time value conversion there. Just the total amount is the accumulated amount of all of them. So 53,876. But then the formula, I have that one on here too? Yeah. So what if you solve for the factor? The factor should be 4.310125, and that's how many digits of precision? 1, 2, 3, 4, 5, 6, 7. And in the end, I'm going to have 1, 2, 3, 4, 5, 6, 7. So that's good. That's what I need. I probably even had more than that in my calculator, more precision. But the idea is this equation will tell you the ratio of F to A. So that if you solve for the factor and then you multiply it by A, then that'll give you the magnitude of F. And as I wrote on the whiteboard here, in find F given A, they assume that the A is in the same year, the last A is in the same year as the F. So that's a little bit different from find P given A, because in a find P given A, the first annual amount is in year 1 and the present is times 0. So there's kind of a gap between the present, which is what you're solving for, and the beginning of the annual series. But here, the end of the annual series is at the same instant as the future. So that's why we can use this formula and get the same amount either way. 53,876 and 56 cents. All right, and then there was one more problem as well, right? Number 6. We didn't look at the solution to that one yet. What'd you get for number 6? If you want to receive $95,000 next year at 9% interest, then how much should you deposit today? $87,155 and 96 cents. Did anybody else get that as well? Yeah. All right. Well, good. It is 5:14. We're out of time. Remember that the next assignment, the first assignment, is due Thursday before class. So please have that uploaded to Blackboard before 4 o'clock. And make sure that when you turn it into a PDF that you've got good lighting, that it's in focus, that it's good contrast. Make sure it's a readable image so that when I grade your work I can see all the great things that you've done there. All right, well, let me know if you have any questions. I'll be happy to help you on the assignment. Just send me an email or stop by my office if you need help.